Okay, here are a few more examples of working with scientific notation. In this case, we're multiplying a couple numbers in scientific notation, then we're dividing a couple numbers in scientific notation, and then we're going to take a number in scientific notation to a power. So let's look at this first one. And the thing to remember here is that when you're multiplying numbers, if they're all being multiplied. So notice that, in fact, I don't even need the parentheses. I could say these things without the parentheses. Everything's being multiplied. And when we're multiplying real numbers, we can order them in any way that I want. So what I'm trying to get at is that I can go past this 10 to the 5th and look at 2 times 3 and call that 6 times, and then the 10 to the 5th times 10 to the negative 7th are over here on the other side. Now, since the 10 to the 5th and 10 to the negative 7th have the same base of 10, we can add the exponents using the exponent rule. So this becomes then 6 times 10 to the 5 minus 7 is negative 2, and I'm just going to leave it like that. 6 times 10 to the negative 2 as my final result. Okay. Now let's look at division. Now, division. With the division here, we can look at the numbers in front by themselves if you'd like, just as their own fraction, you could say. Or in other words, I can reduce these guys. Okay, 8 over 4, that reduces to 2. So this is a divided by 4, that's a 2. Divided by 4, that's a 1. All right. So I'm looking at 2 over 1, which is just 2, times 10 to the 9th over 10 to the 15th. And again, I can use the exponent rule, in this case the subtraction rule, to tell me that I should end up with 10 to the 9 minus 15 power. So this comes out as 2 times 10 to the negative 6 power. And that's it. There's the correct scientific notation way to write that. Piece of cake. Okay. For the next one, I'm going to take advantage of the exponent rule that says I can distribute the power to the powers. Remember, if you don't see a power on a number, the power is 1. So I'm going to distribute this power to this and this power to that. And this gives me then 3 cubed times 10 to the 12th. Now, you can only distribute the power to the powers if this is a product or a fraction, okay? But if this is a plus or a minus, it doesn't work like that, so be careful with that. All right, then 3 to the 3rd power is 27 times 10 to the 12th. And this looks like scientific notation, but it's not. Remember, this is one of those cases where the number in front is not between 1 and 10, and it has to be. So I'm going to rewrite this number in front all by itself as a number in scientific notation. And that number would be 2.7 times 10 to the 1. I hope you agree with me that indeed 27 and 2.7 times 10 to the 1st power, simply times 10, is the same number. And now I've still got times 10 to the 12th on the outside. Then, using an exponent rule, I can combine these guys right here. So I end up in the end with 2.7 times 10 to the 13th power. And there's my final result, correctly written in scientific notation. So thanks for watching. Hopefully there's more to come.